So as you can see, objectives 9 and 10, we're going to be finding trig values of angles in a right triangle. So we're going to define sine, cosine, tangent. Again, defined those the other day. And then we're going to find the trig values of special angles in the unit circle for objective 10. And so for objective 9, let's go ahead and draw a right triangle. It's not necessarily any special right triangle, but let's label the angles as angles A, B, and C. And let's let angle C be the right angle. So we have a right triangle, and let's go ahead and label the lengths of the sides of the right triangle 3, 4, and 5. And so we know, based on what we've learned in geometry, that we have the SOHCAHTOA and the sine of an angle. This says that the sine of an angle, sine of any angle, let's call it A here, which would be the opposite over the hypotenuse. That's the O and the H, opposite over hypotenuse. So one of the things that students sometimes get tripped up on is what's the opposite, what's the hypotenuse, and what's the adjacent. So that's why I want to do a quick example here. The sine of A, so when you look at the angle A has two legs associated with it, and there's always a hypotenuse. In every right triangle, there's two legs and a hypotenuse. Relative to angle A, there's an opposite leg. That's what the O and the A mean. The opposite leg, not side necessarily, it's just opposite leg. And the A is the adjacent leg. So that helps us to not get confused about putting this 5 in there. The 5 is always, the longest side is always going to be the hypotenuse. So that helps us to understand, when we understand the adjacent leg and opposite leg, then again it's easy to just kind of stay on track. So let's take a look. The sine of A equals the opposite leg, which opposite leg to angle A would be opposite, the leg that's not touching angle A, it's opposite, so that's a 3. And then the hypotenuse, that's the 5, it's always the longest side. And so we could do that all day long. We could sit there and say, okay, well, what's the sine of angle B? Still the opposite over the hypotenuse, but angle B, the opposite leg to angle B, is the side that's not touching angle B. And that's the side that has the length of 4. So the sine of B is 4 over the hypotenuse, again, which is 5. And we could do the same thing for the cosine and the tangent. So the cosine of angle A is the adjacent leg. Again, that's the key I want you to make sure, key term I want you to make sure you understand. It's not just the adjacent side, it's the adjacent leg, because there's two adjacent sides to angle A. There's a 5 and a 4, but one is a leg and one is a hypotenuse. So if you just remember leg versus hypotenuse, then you're good. So the adjacent leg to angle A is 4, has a length of 4. So the cosine of angle A is the adjacent leg over the hypotenuse, so it's 4 over 5. And then we have the cosine of B, which again is the adjacent. Still, the cosine, the angle changes, but the ratio doesn't change in terms of how you get the cosine of an angle. It's always the adjacent leg over the hypotenuse. Well, the adjacent leg to angle B has a length of 3, and the hypotenuse still has a length of 5. And then finally, we know that the tangent of any angle is equal to the opposite leg over the adjacent leg. And so we have opposite leg to angle A is 3, has a length of 3, and the adjacent leg to angle A has a length of 4. And then I'm not thinking you need this too much after all of these examples, but nevertheless, last one is tangent of B is the opposite over the adjacent, and the opposite is 4, and the adjacent is 3. So that takes care of objective 9. So you look at a right triangle, maybe you'll have to actually come up with an angle or a side length. So maybe you get A, B, and C. I should use different letters here just in case someone sees this later. D, E, and F. So if we have D, E, and F, and we have a 5 here and a 12 here, then and you're asked to find the sine of angle D. Sine of angle D, still the opposite over the hypotenuse, but they don't give you the hypotenuse, so maybe you'll have to work for that a little bit. Maybe you have to find the hypotenuse, and if you know the Pythagorean triple, 5, 12, 13, then you would know, oh, that's a 13. So the opposite leg is 12. The hypotenuse is 13. So you could still do it if they don't give you one of the sides. It's just you have to use your knowledge of the Pythagorean theorem and find the third side. So that's what you would do just in case you have to do a problem that you don't get all three sides. And I guess we can make it even harder by not having a side and then having it be a square root or something like that. But nevertheless, that's the concept for finding trig values of angles in a right triangle. You can always find the lengths of the sides by using the Pythagorean theorem, the way you've learned how to do. And that's it. So the next video will be our video explaining how we do objective 10.